All right, graphing piecewise functions. Fun stuff. So, a function created by two or more functions is what a piecewise function is. Each portion of the piecewise contains its own domain. And so the domain part is given right here. This tells you like which one to use. So, for example, this function is when x is less than -3. This function is when x is between -3 and 7. And then this function would be when x is greater than or equal to 7. Okay? And another note here, if it is like less than or equal to or greater than or equal to, that means we're going to put a closed circle there because there's actually a point. If it's just less than or greater than, that's an open circle because it's going to get really close to that point, but it doesn't actually ever touch that point. Okay? So let's just evaluate some of this. So like f of -5. Well, first I need to figure out which one do I use. So if it helps, like you can think of a number line. So we have -3 and 7. -5 is right here. So that would be the 2x minus 5 absolute value. So then I'm just going to plug in -5 for that. So 2 times -5 minus 5 absolute value, which would be 2 times the absolute value of -10, which is 2 times 10, which is 20. So f of -5 equals 20. Okay. F of 2, well, that would be that middle function. That would be -2 squared plus 4 times 2, which is -4 plus 8, which is 4. Okay. Now, f of 7. Now, the middle one has 7 and so does the bottom one. So you have to determine, like, which one do I use? Use the bottom one because it's greater than or equal to 7. So it'd be that bottom one. So 2 times 7 plus 6. That's the square root of 14 plus 6, which is the square root of 20. If you break down that square root, you get 2 square roots of 5. Okay? Easy enough. Remember, you don't get a calculator on the test, so I would just leave it as a square root. Now, this bottom one, so if we're trying to find g of -3, well, -3 is between -4 and -2. And it just says 8, which means that this just equals 8. There's nothing to plug in. From -4 to -2, it's just a straight line at 8. Okay. G of -8, well, that would be that top one. So -2 times -8 cubed. -8 cubed is -512. There's nothing super hard like that you're going to have to do on the test, just so you know. I mean, that's not super hard. You could do that, but which would be -256. Now, this step function, we need to be able to, like, know how to recognize this. So if you remember the step function, we have, I'll do it in black. So we have, like, a closed circle and then an open circle. Closed circle, open circle, closed circle, open circle. So let's just, like, guess for a second. I'm going to call this f of x equals the greatest integer of x. So say they wanted to know like f of 1.2. Well, 1.2 is like right here. So that would equal 1. So I always go back. So if I wanted to find like f of 7.9, that's going to equal 7. My points are not really showing up. If I want to do like f of -0.3, well, -0.3 is like right here, so that's going to equal -1. Does that make sense? So like f of -3.1 would equal -4. Okay, so let's look at this. So you always just go back. Like when you're plugging into the step function, just go back. Okay, so if I'm plugging in 3.1, that's going to be 3.1 minus 4, which 3.1 minus 4 is -0.9. So I'm going to go back. That's the same thing as negative 1. Okay, hopefully that makes sense. You always just go back to the whole number. Okay, let's actually graph some of these. So the easiest way I found to graph these, I'm going to start with, it says x is less than 0 or x is greater than or equal to 0. So I'm going to put a dotted line at 0. That tells me that's like where I'm breaking the function up. And I know how to graph these things. So like the absolute value of x plus 3 minus 1, well, that moves left 3 and down 1. So my starting point would be right there. Then we just go over 1, up 1, over 1, up 1. Now notice I put an open circle right on the line of x equals 0. And I did that because it's x is less than 0. It's not less than or equal to. So that's what the left side of the graph looks like. Now the right side of the graph, you can just use mx plus b. So I'm going to go down 5. That's where I'm starting, and it's a closed circle. Then my slope is 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And there's that. Okay. So the domain here would be negative infinity to infinity, because even though this is an open circle right there, it just jumps down to this point right there. So we have points all along the x-axis here. Now the range, the smallest this ever is negative 5. And then that goes up to infinity. And then discontinuities is, there's a jump at x equals 0. I say that different every time. Like, I don't know if it's discontinuities or discontinuities. I think it's discontinuities. But regardless, let's look at this one. So I'm going to go to negative 3 and draw my dotted line. Now, I'm going to just use scratch work here. So say, like, you get to the test and you're like, I don't remember how to graph this. You can always do points. So the left side of this is negative 4 minus x. The right side would be negative 1/2 x squared. So if it's negative 4 minus x, and it's less than or equal to negative 3, I can create a table and go negative 3, negative 4, negative 5, negative 6, negative 7. And then I can just literally plug in points. So negative 4 minus negative 3, well, that's really negative 4 plus 3 would be negative 1. Negative 4 minus negative 4 is negative 4 plus 4, which is 0. Negative 4 plus 5 is 1, 2, 3. So I would just be plugging points in to this up here. Okay. And then it's just like plotting points. So it's less than or equal to, so that would be a closed circle. And then I just plot the points. That's what that side of the graph looks like. Now the right side is negative 1/2 x squared. And it's when it's greater than negative 3. So negative 3, negative 2, negative 1, 0, 1. And I always go about 5 points. You could go more or less. But that gives you a general picture. So if I plug in negative 3, that'd be 9 times 1/2 is negative 4.5. 4 times negative 1/2 is negative 2. 1 times negative 1/2 is negative 0.5. 0, negative 0.5. So at negative 3, negative 4.5, I have an open circle because it's just greater than. Negative 2, negative 2, negative 1, 0.5, 0, 0, 1, negative 0.5, and it's that upside down parabola there. So my domain, negative infinity to infinity. Range is also negative infinity to infinity, and then there's a jump at x equals negative 3. Okay, not too bad. I want you pause this real quick, and I want you to do this one. So notice I changed that right there. It should be x is greater than 1. I think I put 0, and we want it to be 1. Okay, so when we graph this, you should end up with something that looks like that. So I use, the left side is 4 over x plus 3. So negative 3 is my asymptote. And then I plugged in points. Like, you don't have to plug in points, but notice it gave me some so I could get a general shape here. And then the right side, I have 2x minus 7, so I can just graph that. That one is an open circle on that line. Domain is negative infinity to negative 3 because there's no points on that asymptote. Negative 3 to infinity. Range is negative infinity to infinity because even though we have an asymptote right here, there's a point over here on this side of the graph. And then I have an asymptote at x equals negative 3 and a jump at x equals not 0. Whoopsie, it'd be a jump at x equals 1. Okay. Okay, let's do this one. So this time we have 3. So I'm going to put a line at negative 4, and I'm going to put one at 2. So I'm going to say that first part is 3x plus 8, and the second part is negative 1, and the third part is x minus 2 squared minus 5. So I'm going to start with the 3x plus 8, and I'm just going to go from negative 4, so it's all values less than negative 4, so negative 4, negative 5, negative 6, negative 7, negative 8. Now if I plug in negative 4, that'd be 3 times negative 4 is negative 12, plus 8 is negative 4. 5 is negative 7, negative 10, negative 13, negative 16. You could figure that out. And then it's a closed circle. And I could plot the points. Only 3 of them fit. But it looks like that. Now that middle part, it just says negative 1 from negative 4 to 2. And it includes the 2. So that means I'm just going to draw a horizontal line at negative 1. And it's an open circle at negative 4 and a closed circle at 2. Okay, easy enough. And this one you could use transformations, pretty easy to graph this. Or you could draw a table again. 2, 3, 4, 5, 6. Plug in numbers. So it'd be negative 5, negative 4, 1, 4, 11. So that's like the right side of a parabola there. Okay, and it's an open circle because it's greater than 2. Now the domain here is negative infinity to infinity. So is the range. But we have 2 jumps at x equals negative 4 and x equals 2. Okay. Hopefully not too bad. I want you to do this one right here. So pause the video, go through it. Hopefully you paused it. Here's what the answer is to this one. So notice it's at 7 when x is less than negative 1. So we just have this straight line there at 7. X cubed minus 1 from negative 1 to 2, and it includes both those points. And then negative 2x plus 1. Notice here, I used values I knew were going to come out nice. So I knew that like if I plug in 2 right there, I'm going to end up with the square root of 4. If I plug in 4.5, I end up with the square root of 9. If I plug in 8, I end up with the square root of 16. So I plugged in numbers I knew were going to give me nice answers because just like thinking forward, you're not going to get a calculator. You need to know how to kind of think through that. Okay. Now, domain here is negative infinity to infinity. Range is negative infinity to 7. Then we have jumps at negative 1 and 2. Okay. And that is it. Please do the homework. Be good to the sub. I will see you guys on Thursday.